What is the difference between top-down and bottom-up nanofabrication? Imagine trying to build a tiny castle out of sand. You could carve it from a big block or assemble it piece by piece. That's the core idea behind nanofabrication methods. When scientists work at the scale of atoms and molecules, they use two main approaches. One is like sculpting a big block into a tiny shape, and the other is like stacking individual bricks from something complex. These are called top-down and bottom-up nanofabrication. Top-down nanofabrication is similar to carving a sculpture from a large piece of stone. You start with a big chunk of material, often many micrometers or even millimeters wide. Then, you remove parts of it step by step until you get the tiny structure you want. Think of using a laser or electron beam to etch away material in specific patterns. Photolithography is a common technique here, where light shines through a mask onto a light-sensitive layer called photoresist. The exposed areas are then etched away chemically or with plasma. This process can produce structures as small as 7 nanometers, which is incredibly tiny. It's fast, scalable, and perfect for making millions of chips or tiny electronic parts. But it's mostly two-dimensional, so making complex three-dimensional shapes is tricky with this method. Now, bottom-up nanofabrication is quite the opposite. Instead of carving away material, you build structures by adding atoms or molecules one at a time. It's like constructing a house by stacking individual bricks. Nature does this all the time, like how proteins fold or crystals grow. Scientists use techniques like chemical vapor deposition, where gases react on a surface to form thin films, or self-assembly, where molecules naturally organize into specific shapes without external help. For example, quantum dots are tiny semiconductor particles made by self-assembling atoms into precise nanoscale sizes. This method is very efficient because it creates very little waste and can produce highly intricate structures. But it takes more time and control to get the exact shape you want. The real magic happens when these two methods are combined. For example, in making advanced computer chips, top-down techniques create the overall pattern, and bottom-up methods fill in the tiny details. The semiconductor industry uses extreme ultraviolet lithography to produce structures as small as 7 nanometers. Meanwhile, quantum dots for displays and solar cells are mostly made through bottom-up self-assembly because it's easier to control at the nanoscale. So, the main difference is that top-down removes material from a larger block to get the shape, while bottom-up builds structures by assembling atoms or molecules. Both are essential in the world of nanotechnology, and scientists often use both to push the limits of what's possible at such a tiny scale.